Hello, hello. Good morning. Good morning, all of you. Myself, Dr. Kumar Usha, and today we are discussing about the law of thermodynamics. First object of this lecture, आज हम पढ़ेंगे various law of thermodynamics, discuss the importance of law of thermodynamics, study the utility of thermodynamics laws and limitation of these laws. तो सबसे पहले हम इसमें जाएंगे कि थर्मोडायनामिक्स की डेफिनेशन क्या होती है. Thermodynamics, it is the branch of physics which deals with the conversion of heat energy into the other form of energy and describe the conversion quantitatively. एक हीट एनर्जी दूसरी हीट एनर्जी में कैसे कन्वर्ट होगी, हीट एनर्जी को मैकेनिकल वर्क में कैसे कन्वर्ट करेंगे, कन्वर्जन कैसे होगा, किस डायरेक्शन में होगा, उसका स्टडी करना और कन्वर्जन को फॉर्मुलेशन करना. इट इज द एम ऑफ थर्मोडायनामिक्स. द स्कोप ऑफ थर्मोडायनामिक्स हैव बीन enlarged to cover conversion of heat energy to other forms like mechanical energy, electrical energy, magnetic energy, chemical energy, etc. थर्मोडायनामिक्स डील्स विद मेजर और मैक्रोस्कोपिक प्रॉपर्टी. मेजर प्रॉपर्टीज को ये कवर करता है. मेजर प्रॉपर्टी जैसे किसी प्रेशर है, वॉल्यूम है, टेम्परेचर है, इंटरनल एनर्जी ऑफ द सिस्टम. बट इट डज नॉट डील विद इंटरनल स्ट्रक्चर एंड नेचर ऑफ मोशन ऑफ द पार्टिकल्स. जैसे मॉलिक्यूल्स के पार्टिकल से मतलब नहीं है, एटम से मतलब नहीं है. इट ओनली डील्स विद द लार्ज बिहेवियर ऑफ द सिस्टम. Now, we start the laws of thermodynamics. Thermodynamics, the study of thermodynamics is based upon the experimentally derived laws called law of thermodynamics. And these laws starts from zeroth law of thermodynamics. Before study the zeroth law, we should study the thermal equilibrium. A system is said to be in thermal equilibrium if the temperature of the various parts of the system is same. When a system is in thermal equilibrium, no transfer of heat heat takes place फ्रॉम द सिस्टम टू द सराउंडिंग्स. क्योंकि अगर इक्वल टेम्परेचर होगा दो सिस्टम का, दो से सराउंडिंग और सिस्टम का अगर टेम्परेचर इक्वल है, उस कंडीशन में टेम्परेचर कन्वर्जन संभव नहीं होता है. विच मीन्स दैट टेम्परेचर ऑफ सराउंडिंग एंड सिस्टम्स बिकम सेम. फर्स्ट जीरोथ लॉ बताता है कि कन्वर्जन कब नहीं होगा, अगर या दो सिस्टम या तीन सिस्टम कब थर्मल इक्विलिब्रियम में है. तो इट स्टेट्स दैट if two systems are separately in thermal equilibrium with third one, then they are thermal equilibrium with each other. For example, अगर हम तीन substance मानते हैं, तीन bodies मानते हैं A, B, C. If A and B is in thermal equilibrium and B and C is also in thermal equilibrium, then it is generally understood that A, B, C are in thermal equilibrium. Now, we state first law of thermodynamics. First law of thermodynamics, it is the law which states that work can be converted into energy and energy can be converted into work. So from the work of Count Rumford and Dr. Joule, it was established that heat and mechanical work are interconvertible and definite relationship exists between them. Thus, W is directly proportional to Q or W is equal to JQ. Here, Q is the amount of heat produced on conversion, W. Unit of mechanical energy, J constant called Joule's mechanical equivalent of heat. If heat is measured in calories, W in joules, then J is equal to 4.186 joules per calorie. If Q and W are measured in semi-units, then J is equal to 1, so W is equal to 1. This law states clearly that work and heat energy can be convertible. First law of thermodynamics, when a certain amount of work done, an equivalent amount of heat is produced and certain amount of heat is absorbed, then equivalent amount of work is done. This statement clearly states that 100% conversion of work into energy into work is possible, but Clausius put a statement of first law of thermodynamics in differential form as dq is equal to du plus dw, where dq is the small amount of heat absorbed, du is the increase in internal energy, and dw is the external work done. For cyclic process where the internal energy becomes zero, it becomes q equal to w. Utility and limitations क्या है फर्स्ट लॉ के. तो फर्स्ट लॉ of thermodynamics states that conversion of heat into energy into mechanical energy and vice versa is possible. But there are two major limitations for the first law of thermodynamics. First, it does not give us information. ये हमें नहीं बताता है कि किस डायरेक्शन में चेंज होगा, डायरेक्शन इन विच चेंज विल टेक प्लेस, और दूसरा किस क्वांटम ऑफ एनर्जी से ये चेंज होगा. तो इट डज नॉट टेल अस द अमाउंट ऑफ एनर्जी, क्वांटम ऑफ एनर्जी विच विल चेंज फ्रॉम वन फॉर्म टू अदर. The physical concept of temperature determines the direction of flow of heat, which is not included in the first law. It is simply, it is generally known that the heat always transfer from hot energy, hotter body to the colder body, but it does not include in this law. Similarly, अब दूसरा एग्जांपल लेते हैं कि इफ ए बुलेट, एक अगर मान लो किसी बंदूक से गोली चलती है, देन द बैरल बिकम heated and bullet it is cold. So it is actually it is not explained why the hot bullet cannot be entered, is not entered into blood. Yeah, it does not move back into rifle. सेकेंड लॉ ऑफ थर्मोडायनामिक्स, सेकेंड लॉ ऑफ थर्मोडायनामिक्स में अब क्या है कि सेकेंड लॉ ऑफ थर्मोडायनामिक्स इज फॉर्मुलेटेड टू ओवरकम द डिफिकल्टी नॉट एक्सप्लेन्ड बाय द फर्स्ट लॉ. फर्स्ट लॉ में क्या था, सिंपली इट सेज दैट वर्क इज कन्वर्ट इनटू एनर्जी एंड एनर्जी कन्वर्ट इनटू वर्क, बट इन व्हाट क्वांटिटी, इन व्हाट डायरेक्शन, इट डज नॉट एक्सप्लेन. So first, there are various statement of second law of thermodynamics. Lord Kelvin statement: it is impossible to derive continuous supply of energy from a body by cooling it below the coldest of the surrounding. सीधी सी बात है कि अगर हम किसी बॉडी से, कोल्ड बॉडी से हॉट बॉडी की तरफ, हॉट सिस्टम की तरफ अगर एनर्जी को हम ट्रांसफर करना चाहते हैं तो विदाउट सप्लाई ऑफ एक्सटर्नल एनर्जी इट इज नॉट पॉसिबल. नाउ Clausius statement: it is possible for a self-acting machine unaided by any external agency. It is impossible for a self-acting machine unaided by any external agency to convey heat from a body at lower temperature to the other body at higher temperature, or heat by itself cannot pass from a cold body to the hot body. Planck's statement, Planck-Kelvin statement क्या कहता है? It is impossible to construct a heat engine operating in cycles which exert heat from a reservoir and converts it the whole into. तो सेकेंड लॉ ऑफ थर्मोडायनामिक्स इज इट इम्पोजेस द बैरियर रिस्ट्रिक्शन टू द एप्लीकेशन ऑफ फर्स्ट लॉ. अकॉर्डिंग टू क्लाजियस, फर्स्ट लॉ ऑफ थर्मोडायनामिक्स implies that total energy of the universe remains constant, and the second law tells us that the entropy of the universe remains constant maximum. Second law tells us that entropy of the universe tends to have a maximum value, law of increase of entropy. The second law thermodynamics can also be stated in form of entropy, that is dq is equal to tdx. This relation is the mathematical formulation of the second law. अब significant क्या है, क्या मतलब है second law of thermodynamics का? तो the second law of thermodynamics imposes condition under which conversion may take place of heat into work. According to this law, there must be another body older than one from which heat is to be absorbed or converted into work. This law provides the concept of source and sink. Source, a heat reservoir at high temperature from which heat can be withdrawn, and body, sink क्या है? Sink is a body at lower temperature to which energy can be given. Further, this law puts restriction on the conversion. This conversion of heat into work is only partial, and conversion will not be possible when source and sink are brought at the same temperature. Simply, this is again the first law, which states that if the temperature of the system is in equilibrium, system is in thermal equilibrium, then the transfer of heat is not possible. So the second law restricts the operation of the first law. Now it is third law. Now rest heat law or third law of thermodynamics. The concept of absolute zero. It depends on the concept of absolute zero given by the Kelvin. The concept of absolute zero temperature was given by Lord Kelvin on Kelvin thermodynamic scale of temperature in terms of mechanical energy or work, and is independent of property of any substance. The absolute zero on Kelvin's scale is defined as the temperature at which a system undergoes an isothermal reversible process without rejecting any heat to the sink, and there is no thermal motion at absolute zero, and molecules are said to be in perpetuum. That is, this temperature, the entropy at this temperature, the entropy tends to zero. This was first assumed by Nernst and is known as Nernst heat law. Now, third law of thermodynamics. Third law of thermodynamics, it forwarded the Nernst heat law, and this law states that the entropy changes associated with any isothermal reversible process of condensed system approaches zero as the temperature is reduced to zero. One of the consequences of this law is that the absolute zero is the temperature at which can be approached asymptotically and cannot be attained by any actual practice. However, idealized it may be. Thus, the third law may also be stated that it is impossible by any means to reduce any system to the absolute zero temperature in finite number of operations. This law also restrict say that the absolute zero temperature is not attainable कि हम इसको attain नहीं कर सकते. Statically, this law can be written as S is equal to K log W, at T is equal to 0, W is equal to probability become 1, S is equal to 0. So, the entropy of the system is 0. The absolute 0 is the temperature at which the entropy of thermodynamic system is 0 and further cooling is not possible. तो वी हैव हमने हमने इस तरह से तीन थर्मोडायनामिक लॉ पढ़े. पहला जीरोथ लॉ विच एक्सप्लेन या विच डिफाइन द थर्मल इक्विलिब्रियम. फर्स्ट first law gives the which gives us the conversion of heat energy into work and work energy into heat. Second law which restricts the operation of first law dq is equal to du plus dw, and again last my third law which define the entropy in terms of temperature. If temperature tends to zero, then entropy becomes also zero. Also from this law it is also concluded, we are known that the absolute temperature cannot be attainable practically. From this study, we concluded study of various thermodynamic law, the consequences of these law in thermodynamics, limitation of each law and utility of the law, interconnection of these laws in various aspects, concept of entropy and absolute zero temperature and their relation. Their relation also here studied. Okay, this is the end of this short lecture. The end, and with thanks. Any question which can be asked. Okay. Okay. Thank you.